guys, we're going to do I'm going to explain to y'all how to do a Riemann sum with n equals 2, m equals 2. This might be a two-part video. I'm going to get as much as I can right now with this, with all of the process, and to that end I couldn't just kind of neatly write it in time. They just take too long. So, in at least my opinion. So what I'm going to do is I'm just going to go over this and show y'all how to do that. Okay, so let's begin. Now, first thing you want to do is they gave us n equals 2, m equals 2, and they say to calculate the double integral using midpoints. They're giving the function x minus 3y squared. That's this graph over here. I went ahead and included the subdomain that I'm going to show you how to get right here and here in x and y, and beneath the function surface here. You can see the x z trace and the y z trace right here, respectfully. Now, we will be taking each surface area element midpoint that we get, our little dA point here, and we're going to be multiplying it times that height. So for example, I went ahead and put one of the midpoints ahead of time for 3/2 and 5/4. I'm going to show you how to get, when we plug that into our function x minus 3y squared, we will in fact get a height here. We will multiply it times that dA, and we will get that representative volume slice there. And we're going to keep doing that for the other 4 of those. So let's go ahead and get our delta x and delta y. Here's your formula for your Riemann sum, the function, and I did a table for midpoints over here. So let's start. So now in this problem you have, let me change this up just a slight bit for another color here because it's just, I don't want it too much. So they gave us 0 to 2 for x, and y was from 1 to 2. Now, you take, if they gave you that n is equal to 2 and m is equal to 2, what I like to do is just multiply that to know how many rectangles I get. And I make a little like a domain rectangular plot. I'll put a 1 to 2 for y here, and then kind of slice that in half to make 2 rectangles. And that's a nice little trick here, by the way. And then you can go ahead and go from 0 to 2 in x and cut that in half, and you're down to your 4 rectangles. Just make sure it's symmetric. Now, the way you would get that without that is you would take your now go ahead, let's get this first. You need to do your upper bound for x minus your lower bound divided by m slices to get 1 here. That's your change in x in this example. And for your change in y, it's going to be your upper minus your lower bound divided by the 2 slices there they gave you for n equals 2. That's going to give you 1/2. Now, you take that, you're going to find this little surface area element formula, right? Or delta y times delta x. 1/2 times 1 gives you 1/2. That's going to be this part here. Now, you know, naturally, this part right here is going to be the same no matter what. It's just 1/2, so it factors out. So when we plug that in later, that's going to be easy down here. So now, and I'll kind of show you all that right there. You can pause it and just kind of ahead of time. x1, y1 height, that's right here. x1, y2 midpoint height, that's right here. And then your x2, y1 and your x2, y2. Anyway. So, and then this is the subdomain plot version of that. Now, to show you how I got this, we're going to have to go a little quicker. We have x sub I minus 1 plus delta x. That's going to be, and by the way, my name's Colton Earl. If you want to set up tutoring, give me a call, 512-564-3744. I'll be more than happy to help you with the courses. It's much better if you have me in person, so don't hesitate to call, and I'll help you out with your courses. I do Cal 1, 2, and 3 and all this. So now, also chemistry. But for this, our x of ith, right, we want our x1 point, the next point in line. We know we're starting at 0. So I plug this into my formula, x sub I minus 1 plus our delta x that we calculated. That's going to be x sub 1 is equal to x 1 minus 1. That's the initial x0. That's going to be 0. And we're going to add our change in x there, that's 1. So 0 plus 1 is 1, and we have our next point, x1 there. If you look at the graph over here, that's what this is. So now to get the second point, you just repeat that process. You plug in the x1, right? So 2 minus 1 gives you your x sub 1 plus your delta x. That's going to be 1 plus 1 is equal to 2. So pause the video if you need to see that. Now, anytime I'm going too fast, just pause the video. It's that easy, right? So y sub j is equal to y sub j minus 1 plus delta y. You're going to take that as for our first y point, or not our first, but our next one in sequence, you're going to take that 1 minus 1 here in your little formula subscript. That's going to give you your initial y, you know, to plug in. We know we're starting at 1. That's the lower bound, of course, just so you know. And then plus your delta y there, which is 1/2, which is what we calculated above. Once again, we are starting at x0 is 0 and y0 is 1, right? So I just want to hint on that in case you're kind of you're in a number frenzy, right? So then now that's going to give me 1 plus 1/2 is 3/2, and that's my next point. You repeat the process, plugging y sub 1 right in there, and then of course you do your delta y, which is 1/2, respectfully. Now that's going to give you 3/2 plus 1/2, which is 2. Not bad. So let's get going. We're already at 6 minutes. We got 4 left. So now to get your midpoints, we're going to use the midpoint formula we're familiar with, right? X sub I minus 1 plus xi, and the same thing for y, j minus 1 plus yj, both divided by 2 independently. Now you've got your x1, y1 on your rectangle that we're going to need to have, so that's going to be 0, respectfully, plus 1, divided by 2, which gives me 1/2 here. And I went ahead and included that over here. So this is a little messy, make your own chart, right? But let me go ahead and do this real fast if I have time. I'll go back to that magenta color. So 1/2 there. And then for the y, it's the same. Your initial y started at lower bound 1 plus your 3/2. That was the next y that we had calculated over there, remember? So on that chart, there's the 3/2 there. And our next was 2, so we're getting this midpoint here, respectfully. We already did the x portion, which was 1/2, and now we're getting that y portion here in a minute, which is going to give us 5/4. And there it is. There's our little area element where we're going to multiply our height. Now, so let's go ahead and calculate that. 1 plus the next y that I showed you on the grid over there is going to be 1 plus 3/2, and you're going to divide that by 2. So that's going to give you, and once again, just if you're having a hard time hearing me, that's going to be 3/2 there for our next y portion over 2. That's going to give me 5/4. So this is the coordinate we will be plugging into f of x. You're going to repeat the process, but guess what? You don't have to do it again for x1, right? Because on that rectangle over here, and I got to be quick about this, that's going to be still 1/2 for this one right here that we're going to do. And I'm just going to do these two so I can plug the rest into the function out here to show you the gist of it and give you the answer, because it's just going to be, we got to be quick on this. So this is 3/2. Where am I at? Yeah. So that was for our y2, we're going to have the 3/2 plus the 2 for the that upper rectangle part, x1, y2 midpoint, divided by 2. That's going to give me 7/4 yet again. And again, I'm sorry, x midpoint still 1/2 for that, right? Then you do the same thing here. Your 1 plus 2 is the next x, divided by 2 gives me 3/2 for that x portion. And that's that midpoint that we're going to be plugging into the function. And if it's y1, we already calculated that above, that's 5/4. So a lot of these can be repeated, or you can just look at your rectangle and you're done. So I'll leave it to you to do this last one, you know, a little bit of practice. And let's go over here and plug them in. So I just wanted to show you graphically what's going on. Respectfully, I did in the table show you that x2, y1, and then we plug it into f3, 5/4. I did one to show you because it just, this video's got to go fast. And that point in your expansion here would be your x2, y1, right? That's going to be the negative 51/16 for your height, right? So that's what that little blue height meter means there. Now you plug in your x1, y1 into x minus 3y squared. You plug in your x1, y2 into x minus 3, and I'll do a second video on this to get this. And then you do, like I just said, for that one, you plug it in, and then you plug it in for that one times change in a. I accidentally put delta a there. That goes in the integral. So respectfully, I just wanted to let you know that you can take that area element out when you do this, like I said at the beginning of the video, and you don't have to really worry about redoing it every single time. That's ridiculous. So do all your heights, plug them into your function, add them all up, and then multiply them times dA, and you'll get your answer. I'll do that in another video, and as well I might do another part where I just do the exact iterated integral. Alright, you guys, I'll see you in the next vid. You have a good one.